Hello, and this lesson is all about extracting metals. We live in an age where we make all sorts of stuff about metals, but humans haven't always done that. Back in the Stone Age, we couldn't make metals. We had to make stuff out of stone. So at the end of this lesson, I want you to be able to answer this question. If you were dropped into the Stone Age, could you invent the Bronze Age? Could you invent the Iron Age with the science knowledge that you have learned today? So you would be like top caveman or cavewoman, and you say, do you know what, don't worry about all this stone stuff, I'm going to show you how to make some metal. Now, to make some metal, first of all you need to find a metal ore. Now here is some metal ore, and you Minecraft kids will know all about this kind of stuff. This is called iron ore, and it just looks like a rock, but if you break it open you will see inside it's like a reddish colour, and that reddish colour in there is iron oxide, or rust if you like. And so this is what the locals, where I found this in Northamptonshire, would call ironstone, and in there is iron oxide. Now let me just sit down here and let's have a look at this. So if you got that rock and you got all the red stuff out of it, it would look like this. Okay, see, in that rock, as well as all the red stuff, which is the iron oxide, powdered rust if you like, there's bits of grit and stone and everything. So you've got to get that out, but now you're left with this stuff, and this is called iron oxide. But iron oxide is not iron. Let me see if I've got a magnet up here. There's my magnets. Here's all my magnets all joined together. Now you know that iron is a magnetic material, so if I put this in here, it's stuck to it, but only stuck to it just because it's a little bit damp, so it's not actually magnetic. So this does not behave like iron. And what you want to do if you want to be that top Stone Age person is you want to get your iron oxide and you want to take the oxide away, so you're left with a nice little bit of iron, and then you can go make your axe heads and things like that. Now to do that you have to think back to the last lesson, and in the last lesson we looked at things called displacement reactions, whereby if you had one metal which was more reactive than another metal, it would steal something away from that metal. And here is a reactivity series, and we spoke about reactivity is if something is very keen to react, it's got high reactivity. So one of the most reactive metals we've got is something called potassium. You put that in water, has a very energetic violent reaction with water straight away. And right down the bottom here, if I move all this out of the way, you have something like gold, and gold does not really react with anything at all. So if you find some gold in the ground, you don't find it as gold oxide, you just find it as shiny gold. So enough of that, let's have a look and see how we can use this to get the oxide away from the iron. Now here is iron in the reactivity series, and as long as we can get something above it in the reactivity series to take part, hopefully it should be able to steal that oxide away. Now what I am going to do today is I am going to do some aluminium. I'm going to add some aluminium to the iron oxide. So we're going to say iron oxide plus aluminium, and that hopefully should turn into aluminium oxide, because the aluminium is more reactive, and so it will steal that oxide away. And if you've done that, then you've just got some lovely iron left over, and that's what we're going to do. So let's have a look back here. So here is my iron oxide in here, and here I have got some aluminium and some aluminium powder, a nice shiny aluminium powder. And so if I put that in here, are we going to see a reaction? So watch out, because remember the aluminium is more reactive, so it's going to see that oxide attached to the iron and think, I'm going to have that. So nothing's really happened, has it? Maybe if I give it a stir up, is something going to happen? No, the iron, it's in there, but it's not actually reacting yet. And that's because the iron oxide is a solid, and so the iron is holding on reasonably tight to its oxygen. And so if you want the aluminium to get in there and steal it away, you have to add a little bit of energy to loosen those bonds, to give the iron, the aluminium, that opportunity to go in and do that. So I'm going to go and do that in the garden, and I am going to add quite a bit of heat to that. I'm going to mix it all back together in here. I'm going to have a piece of magnesium ribbon as a fuse so that I can get away. So that's going to put some heat down into there, and then hopefully, fingers crossed, you might see a reaction happen. Okay, should we go back and have a look at that? Now, before we do that, I just want to tell you this is not the way that we usually make iron, because aluminium is really expensive. We normally make iron in a blast furnace, a company that makes iron, and instead of using aluminium, they use carbon. Carbon's not actually a metal, but it is more reactive than iron, and carbon is very, very common. You get that in coal and things like that. So if you can heat carbon with iron, then the carbon will steal the oxygen away and you'll have carbon dioxide and leave the iron on its own. So we were talking about caveman and cavewomen times, weren't we? If you could get your iron hot enough. Now, prehistoric people didn't understand the chemistry, but they understood that if you got iron hot enough in a fire, and the fire will be burning a fuel which has got lots of carbon in it, then you can make that happen. But we didn't start off with the Iron Age. We started off with the Bronze Age. And bronze is a mixture, an alloy, if you like, of copper and tin, and those are much further down the reactivity series, and so they were easier to heat up and make stuff. But then to get iron, you needed to have hotter and hotter fires. So anyway, enough of that. Let's go into the garden and try this experiment and see what happens. Okay, so what I've got here is I've got my aluminium powder and my iron oxide in here. I've got some magnesium ribbon as a fuse. Now, if you come up, there we go. There's your fuse. Burning down, and with a bit of luck, nothing's happening. Okay. Right, I'm really disappointed. That was a terrible, terrible fail, and it just hasn't worked at all. So I'm going to find a video online and post it onto this thing. Okay, science doesn't always work, folks. Right, okay, I've got over my bitter disappointment of the experiment not quite working, but this is what was left. I'm going to try and find a video online of it all working, but you remember when I first started off, I had this magnet, and it wasn't magnetic. Now if I bring that in there, you can see little bits jumping up from the surface, and those tiny little bits jumping up from the surface and sticking to it. There is a little bit of iron in there. Can't really see what I'm doing here, but if you can believe me, there are bits of iron because they're not really shaking off of there. But it should have turned into one massive lump of iron. Anyway, I'm over that now. Right, let me show you a proper video. So instead of attaching a video, I'm going to suggest that you just look on YouTube for a thermite reaction, T-H-E-R-M-I-T-E, and you will see what I was trying to do, and then you can understand why I'm so disappointed. Okay, I will see you next time. Take care.